Welcome to the Math Record. Today we'll be learning about exponential functions. This video will be part 3 of chapter 3 in our Precalculus class. In this video, we will learn the laws of exponents, introduce the idea of exponential functions, and discuss their properties, and solve some exponential equations. Okay, first up, let's learn some exponential laws. There's basically 8 exponential laws you have to know, which are really simple. Let's say you have something with base a, right? If it has base a with exponent y, then a times y, a to the power of x times another one with a to the power of y is the same thing as saying a to the power of x plus y. So whatever this exponent adds up to. So it's like 2 to the 1 times 2 to the 2 is going to equal 2 to the 3, basically. Now, if this one is adding, what would you think would be the dividing? So if a divided by x, a to the power of x divided by a to the power of y, it would just be a to the power of x minus y. Make sure you have the same form, because this is not equivalent to say y minus x. X has to be the first one, minus y has to be the second one. You have to keep the order of operations the same. Okay? So that's the division rule. And then there is the power rule, which says if a is the power of x, which is then raised to another power of y, it says that it's raised to the power x to the power of y. It will be a to the power of x times y. That's basically what it says. So let's say we have 2 to 2, right? And you have that raised to a 2. That'll be 4, and then 4 squared is just 16, right? So if you have 2, this law tells us is 2 times 2 is 4. So 2 times 2 times 2 times 2 is just 16, which is the same thing, so it's equivalent. So that's what our x times y. That's what our power of a power rule means. And then we have kind of like if we have two bases, like we have base a times base b raised to a power of x. This is the same thing as a to the power of x times b to the power of x. Because think about it, it's 6 to the power of 1, like say 2, right? That's equal to 36. 6 can be made into 2 times 3 to the power of 2, which is the same thing as 2 times 2 times 3 times 2, which this is 4, and that is 9, so that equals 36. So this property is true. These are all just laws of exponents that you have to learn. Sorry, a times abx is equal to a x times bx. Okay. The fifth rule you need to know is really basic. If a is to the power of 0 is equal to 1, there's no and if or buts about it. It's just a to 0 is, if the exponent is 0, it's going to be 1. Unless a is like 0 to 0, which then you can't say anything about it. If it's 1 to the 0, it's going to be 1. Or it's 2 to 0 is equal to 1. If it's negative 1 to the power of 0, it's also 1. It doesn't matter. It just can't be 0 to the power of 0. Which then it's kind of strange. So that is our fifth one. Sorry, I forgot one, which is the power of a fraction rule, which says that if a is divided by b, because instead of saying multiplied, it's divided and it's paid to the power of x, it's gonna be the same as a to the power of x divided by b to the power of x. So what this is telling us is, let's say 2 to the power of 2 divided by 5 to the power of 2. This is the same thing as saying 2 to the power of 2 divided by 5 to the power of 2, which is just 4 over 25, right? Because think about it, this is 20%, so 0.2 times 0.2 is 0.04. Wait, is it? No, that's 0.4, sorry. 0.4, this is 0.4, squared is 0.16, which is the same thing as this, which is also 0.16. So it makes sense. So this rule is true also. All these properties are true. I'm just showing you why. And I'm showing you an example. So we already covered the 0 exponent, which is right here. And then we have the negative exponent. Like we have a to the power of negative x. This would be the same thing as 1 over a to the x. So this is just a thing. Just know if it's negative, you put it on the denominator. So and then we're gonna have the fractional exponent, which says if it's a to the power of x divided by y, it's gonna be y, the y root of a to the power of x, basically. So what does this show? Let's say we have something like 2 to the power of 2 to 3, right? So it's gonna be the cube root of 2 to the power of 2. 2 to the power of 2 is just 4. So this thing is the same thing as this. And you could also reverse it. So you could also say this is equivalent to this. So you have like the fifth root of like 5. It will equal to 5. The exponent is 1. And the denominator is 5. So it's 5 to the power of 1 over 5. So those are the rules of the laws of exponents that you had to know, which are also the rules. Now now that we know this, let's introduce the idea of a exponential function. An exponential function is it's like half of a quadratic if you think about it. It was something like this, right? Imagine it. Now an exponential would be something like if it wasn't this, it was just one side. But a quadratic is not the same graph. A exponential function increases way more than a quadratic. So while a quadratic looks like this, it's gotta be something like this. This is gonna become more steep, right? So this is gonna be increased way more until it almost kind of looks like a line, like just a line up. But it's not really gonna be like vertical. Like the line's not gonna be vertical. It's gonna look really really steep, but it's not gonna be vertical. So it's not gonna be undefined basically. So exponential function is used to like calculate basically money, which we're gonna expand on further in the video. But right now we're gonna learn about its properties, which we're gonna talk exponential. We're gonna talk about its domain, and we're gonna talk about its domain, and we're gonna talk about its range. You probably just need to think about it. An exponential function looks something like this, right? It's gonna always be increasing on the right, and it's gonna always be decreasing right here on the left. If it's just y is equal to like some exponential, right? So let's say y is equal to 2 to the power of x. So that's what it looks like. It's gonna always be decreasing right here. Unless it's something like y is equal to like negative 2 to the power of x, then it's gonna look different. But basically, it's gonna be something like this. Yeah, in most cases, the most normal cases. So what it's gonna be is that this, as you see the x-axis, it could go through every single point. So it's gonna go negative infinity to infinity as the domain. The range, as what values can it go through? It cannot go through 0 because it's never gonna cross 0 ever. And it's gonna go through infinity as it moves to the right. It goes to such a big number. So this is the domain and the range. Now let's learn about its intercepts. There is no x-intercepts in here, so there is no zeros. Unless the equation is transitioned down. So let's imagine you have an equation like this, right? And you move the equation down to here, then you're gonna have a 0. But if it's just in normal cases where it's just y is equal to a to the power of x, where a is a number, then it's gonna have no 0. But it's gonna have a y-intercept. It's always gonna have a y-intercept, basically. So asymptotes, like as I discussed in part 1 of chapter 3, which I talked about rational functions, I introduced the idea of asymptotes. There is an asymptote only at y equals to 0, because as the graph is approaching like negative infinity, like to such a really small really a large negative number over here, it's gonna become it's gonna approach the x-axis, and the x-axis is just y is equal to 0. So it's right here. So this would be our horizontal asymptotes. There's not gonna be any vertical asymptotes unless it's like a really weird exponential function. Sorry about that. And that basically covers everything about its properties. So now let's talk about like a really special why these exponential functions are used. These exponential functions are used because of money. Let's put $3 signs. So it's used because of money. It helps calculate interest. You know how, like, let's say you made $300, you have $300, but then you earn like 10%, so in like a second, so you made $30 in interest. Okay, right? So 10% of $300 is $10. I mean $30. So that will be your interest. So that's basically what it states. So what an exponential does is that they help you calculate these amounts. So there's different kind of interest. There is simple interest. There is compound interest. And there's compound continuous. So what you do in these cases is that a simple interest would be like an equation would be represented by uh represented by um you really don't calculate interest. You calculate total money. So how much money you have after. So in our case with like 300 times 10% is equal to 30. What our money will calculate is that it's going to calculate the total amount that you made. So instead of saying it's 30, we're going to say it's 300. I mean 330 because it's 30 plus 300, which is your initial amount and the $30 you made. So you have 330 now in your bank account, I guess. So that's what they do. So what it does is that they say the total money you have is equal to your initial money times 1 plus the rate to the power of x, basically. So let's say you have $300, right? And you're earning 10% each year. How you calculate it is that 300 goes to I, so t is equal to 300 times, 300 times 1 plus 10%, which is just 1.1, because you got to put this in decimal form, to the power of x. So in 1 year, it will be 300 times 1.1. In 2 years, it will be 300 times 1.1. The 1.1 is raised to the power of 2. In 3 years, it will be 300 times 1.1 to the power of 3. So that'll be the total amount in 3 years, basically. In 2 years, it will be x is equal to 2. In 1 year, x equals 1. So that's what it does. That calculates the total amount of money you have each year. So that's simple interest. Compound interest is basically the total amount. It's your initial amount plus 1 plus the rate divided by like this kind of like number raised to that number times x. So basically in this, the r is divided by n, but then it's also raised to that power of n. So what this is saying is that it's not each year, but let's say it's a monthly. So it's compounded monthly. So what it says is that let's say you have $300, right? Instead now, and you're making 10% each month, right? Per year. Right? So it's each month. There's 12 months per year, right? So if there's 12 months per year, it's always going to be out of a year. So you're going to be t is equal to I would be 300. It's 1 plus the percentage is 1.1. 0.1. This is in decimal form. And it's going to be divided by 12. Sorry, I'm going to write it. I'm going to delete a portion of this so I could get more room. Right? So we're going to have the total is equal to 300 times 1 plus, in decimal form, 10% is 0.1 over 12, because that's the amount of months per year, all over to the power of 12x. So you're gonna have to like put this into like some kind of decimal, which I don't want to use right now. But basically, that's how you calculate it. So let's say it's not each month, but it's each a day, right? So it's not gonna be 12 because there's 365 days in a year. So this number is gonna be 0.1 is gonna be divided by 365, and then it's raised by 365, right? So this is what this number would be basically. So that's gonna be compounded. So if it's like per monthly, weekly, or like if it's weekly, it's gonna be 52 because it's gonna be because it's kind of, you have to look at the second part. If it says weekly per month, then you might have to do it out of 4 because there's usually 4 weeks in a month usually. Um, and then there's 52 like weeks in a year. So you gotta think about it. So it's gonna be out of a year. If it's not specified, it's probably most likely out of a year. So you're gonna say like there's 12 months out of a year, 365 days out of a year, or like 52 weeks out of a year. So that's basically that. And now we're gonna talk about the last one, which talks about compounding continuous. Let me delete this first. Okay. Compounding continuous is what is the most basic one. It's, well, not the most basic as simple, but it's one of the most used or most common. What it states is that the total amount is equal to the interest, the initial amount times, not interest, the initial amount, in e to the rate times time. T is the same thing as x. It's just gonna be a variable. Okay. So what it says is that if you have $300 compounded continuously, what it says for like 10% each year, it's gonna give you it's gonna be t is equal to 300 times e to the power of 0.1 times t. So in 1 year, it will be 300 times e to the power of 0.1. And in 2 years, it would be 300 times e to the power of 0.2, because 0.1 times 2 is 0.2. And so you might be asking, what is e? E is basically a number. E is equal to 2.718, etc. It's one of those numbers that is like pi, like the that's related to a circle. E tells us that it's like kind of infinite because this is a really weird number like pi. So it uses to monitor like real life situations because it's, so these compound continuous be like helping to measure a population because population is continuous. It's never gonna stop for like a second, you know. So what it does is compound continuous is helping us like keep track of like populations of the world. So that's how we use it, E. And that's why we have like um so E, how did they get E? Because imagine like we have this equation. This is the part we want to focus on for E. Because what it states is that, let's say we have 1, right? We have whatever the rate is. As the rate, let's say it's the amount of n, right? N is out of a year. So imagine you have like 3,000 times out of a year, or 5,000 times. So if n approaches like infinity, like a really big number, then this number also approaches like an infinity. And this number, like 1 plus whatever the rate is, n to the power infinity, raised to the power infinity times x, approaches e. And we don't really know how to solve what this number is. It's gonna be like pi. It's gonna have a lot of digits, which makes it irrational. Like as I said in like chapter 1, there's different types of numbers. There's irrational, and e is one of them. So basically, so these help us calculate a compound interest. Usually when they ask you to solve a question like this, it's usually in a calculator portion. So you're able to use your calculator. But doing this by hand, it's like really ugly because you're gonna get a bunch of decimals. But basically, in general form, compound interest is just t is the initial amount times e to like the rate times which is the percentage, times t, or you could just write it as x. Doesn't matter. It's just gonna be some kind of variable. So that's what you do for interest. Those are the three main types. Anyways, let's go to like do some of these kind of examples. So let's solve like a interest amount. So let's say usually the type of questions that are presented are like if you have an equation, let's say y is like 300 times 0.2 to the power of x, or like 0.2 to the power of like, let's say 5x, right? And they're asking when would the y value double, like when would the initial amount double. So if this is 300, when would it be 600 basically? So it'll be 600 is equal to 300 times 0.2 and 5x to the power of 5x. So you divide by 300, you get 0.2 is equal to 0.2 to the 5x. And then you use your calculator and you find what x is equal to. And our class would be covering how to solve this precisely without using the well, you're gonna be using a calculator, but you're gonna use a different function, which is called log arithmetics. So if you don't know how to use it now, we're gonna explain it in the next video to how to do this. So basically, this is the general form to how to do it for exponentials, though. So another type of question that like an exponential might have is like what is like the most basic would be like what is the value after 5 years? Or it would just be like y is equal to 300 times 0.2 to 5 times 5. It's basically just that simple. Or it's gonna ask you how long would it take before it reaches like 500? So it's like 500 is equal to like 300 times 0.2 to the power of 5x. And you just divide, and then you get 0.2 to the power of 5x, and you solve for x, basically. We're going to use logarithmetics for this one too, later on in like the next video. And the last question they would usually ask is, well, not the last question, but a question that I seen kind of frequently from teachers when they try to like make the question difficult is that they try to combine an exponential with a quadratic. So what they do is they use something like this. They make y is equal to 2 to the power of 2x. And they have times like, plus like, uh, how would they do this? Wait, plus, like 4 times 2 to the power of x, and then like plus 3 or something. So what they would try to do is like find out when this value is equal to 0. Whenever you see something like this, what you want to do is that you want to solve it just like a quadratic. So imagine 2 to the power of x, usually the middle term, is a variable. So imagine like 2 to x is equal to a. So it would be y is equal to, substitute that in. So that's just, this thing would just be the same thing as 2x to the power of 2 based on our exponential rules. So this would be the same thing as saying a squared plus 4a plus 3. You see how it kind of looks like a quadratic now? So it would be a plus 1 times a plus 3. And you find out a is equal to negative 1 and a is equal to negative 3. And then you have to plug in a is equal to here. So if a is equal to negative 1, that means 2 to the x to the power equals to negative 1. And 2 to the x is equal to negative 3 because of this answer right here. So what you have to do is say, find out when x is equal to negative 1 and when x is equal to negative 3, which is never, because it's never going to become positive. It's never going to become negative. Remember how like the domain and range is something like this, right? The range would never go negative, basically. But imagine if this was not like plus 1 and this is minus 1, right? So we have 2 to the x is equal to 1. Then x has to be equal to 0. Because remember identity rule, anything raised to the power of 0 is to 1, basically. See, that's what it states. So that's how you like solve some of those. If another way you could do this is that if you don't want to do any of the substitution, like you don't want to make the variable a, um, uh, let me just make this a easier, like minus 4 times 2 to the power of x. So we get like some answers actually, plus 3. So let's say we have something like this, right? What we want to do is that you want to write 2x, write a parentheses, but leave room, and then you write 2x again, leave a parentheses, and you find out what multiplies to 3 but gets to -4. So if this is positive and this negative, these have to multiply to a negative. So it's negative times a negative equals a positive, which so a negative plus a negative would just be a negative. So what gets to 3 is -3 and -1. So put that anywhere. And then you have something like this. Anyway, it makes sense, which is just 2x squared using our exponential rules. -3 times 2x and -1 times 2x is the same thing as -4 times 2x. And then plus 3. You say that's equal to 0. And then you have to solve when this is equal to 0. So 2x is equal to 1. And 2x is equal to 3. And you just use your calculator to solve the answers. And you'll get some like decimals. Like, it's not gonna be like pretty. Like, the numbers are gonna be weird. So that basically covers everything about exponential functions. If there's anything I miss, list it in the comments below. Anyways, thanks for watching, and I'll see you at the next math record.